Hello everybody, welcome to the Go language course. In this video, I'm going to discuss the use of pointers. So before I discuss the pointers, I'm going to include the main package. I'm also going to import the fmt package so that I'm able to use the printline function coming from this package, okay? And now we can go to the discussion part. What is a pointer in Go language? A pointer is a variable that stores the memory address of another variable. And in order to denote a pointer, we can use an asterisk before the data type to declare a pointer. So for example, if I say asterisk int, I'm going to make a pointer type of an integer. That means I'm going to make a pointer to point to an integer. And we can also remember to use the ampersand symbol to represent the address operator. So let us see how we can use these symbols. Suppose I have x equals 1, so x is an integer, and this integer has a value of 1. And if I want to produce a pointer to this integer, I can say x pointer here, and the data type of this pointer will be the asterisk followed by the data type that I'm going to point to by using this pointer. So since x is of integer type, I'm going to use int here to represent the data type that I'm going to point to. So in order to give the address, I'm going to use the ampersand symbol here. So ampersand x is meaning the address of x, okay? So xptr is going to store the address of the variable x, okay? And we can just print the address stored in the pointer. And if we want to get back the value pointed by the pointer, we can use the dereferencing operator, which is an asterisk, to help me get back the value pointed by the pointer, okay? So asterisk x pointer is going to get back the content that this pointer is pointing at. So I'm going to refer to x back, which is a value of 1. So let me try to play with the program. Okay, you can see the address coming from the CPU memory management operations, and the CPU decides to give me this position in the memory to store my variable x. And of course, when I do the dereferencing, I'm able to get back the value of 1, okay? And we can modify the value pointed by a pointer by dereferencing. So what does it mean? Let us see. Now I can do something like this. Asterisk x pointer equals 20. So the value pointed by this pointer is actually x. And this x is now going to turn to 20 rather than staying at 1. So if I do the printing, I'm able to see that x will become 20. So let me see the result by running the program. Now you can see that 20 has come out. So initially it was 1, but now after the dereferencing and the modification, it turns to 20, okay? And we can make a pointer without using an asterisk. What does it mean by this sentence? Let us see this example. Now I have a variable y, and this y will have a pointer called y pointer, which is storing the address of y. So remember that the ampersand here is representing the address operator, okay? And when I print the y pointer, I'm able to get the address of this variable y. So let us try to play with it now. Okay, you can see that y is placed at another memory location. So this is the memory location of y. That is the memory location of x, okay? So we have no way to choose the location to store my variables. It is decided by the CPU, okay? And we can see that the address is shown here, okay? So I'm able to make a pointer without using an asterisk, okay? I just use the address operator instead. We can also make a pointer using the new function here. So what does it mean? Let us see this example. I have a variable called setPointer, which is created by using the new function, and I embraced int here. It means that I'm going to make a pointer that is pointing to an integer. And when I do the dereferencing, I'm able to say that the value pointed by this pointer is going to become 3. So let us see the result of the following 2 lines of code. I want to print out the address and the value referenced by the address. So let us see the result. Now you can see that the address here is a location given by the CPU, which is this one. So you can see that the 3 variables that I declared would be stored in 3 different locations in the memory. And when I do the dereferencing here, I'm able to get back the value itself, okay, which is 3. So I can use the new function to make a pointer directly. And the pointer can be new, meaning that the pointer doesn't really store any address. So pointers are new actually by default. What does it mean by this sentence? Let us see this example. I'm going to declare a pointer, so you can expect that the pointer value would become new. And if it is not new, I'm going to print out the value referenced by this pointer. But of course, when I just use this simple sentence, the pointer p is just a new pointer. And then I'm going to do the else part, saying that the pointer is new. So let us see if it is the case or not. Okay, you can see that the pointer is new. That is natural because this sentence here is just making sure that the pointer p is storing no value, which is represented by the new value, okay? So we can see that if I just use this simple sentence, the pointer will be a new pointer, okay? So this video has discussed many things about setting up a pointer. We can use the asterisk together with the data type to denote the pointer type, and I'm able to use the address operator to get the address of a variable. Of course, I'm able to do the dereferencing to get back the value pointed by the pointer. I can modify the value pointed by the pointer. I can also make a pointer without using an asterisk. And I can also make a pointer using the new function. We have to also remember that the pointers will be new by default. This is the end of the video. If you have any questions about my video, please leave your questions on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.